All right, so today we're going to wrap up object-oriented programming by talking about the solid principles, which are basically a restatement of the four basic pillars, but in different, in terms of design, right? Remember that we are online, so if you have any questions, you can go ahead and post to Piazza or to the YouTube live chat. All right, so just jump down here right away here. So the solid principles are an acronym. There are 5 of these principles, and they form this acronym SOLID, S-O-L-I-D. The first one is the single responsibility principle. And again, these principles are just general guidelines with respect to object-oriented programming design. And they give you a general idea about how to go about designing things well. The single responsibility principle is just a restatement, right? It's a simple restatement of good encapsulation. Right? Basically, that a class or object, or however you want to put it, or you can even take this down to a variable or a function, right? A class or method should be responsible for one thing, right? Do one thing and do it well. In other words, don't have God classes. Right? Remember the God class, the class that knows everything, is everything, sees everything. Right? You don't want that. You want to split it up. We did it in class, but we still saw several submissions on the first phase of the project that violated this principle. For example, a person class, right, should be responsible for person things, right? An address class should be responsible for address things, right? So the violation that we saw, not too common, but the violation that we saw was taking those 5 things that make up an address and putting them in the person class. Right? Now this person class knows about all address things and knows about all person things at the same time. And so that's a violation of the single responsibility principle. And it's yet another restatement of another principle that we kind of cover, the DRY principle. Do you remember what that stands for? Do not repeat yourself, right? Repeat yourself. Or don't repeat, so that it fits in the acronym. Don't repeat yourself. There we go. All right. Don't repeat yourself. If you did take the design that you put the address stuff into the person class, then that's not reusable at all. Then if you've got, like I say, a property class, real estate class or something like that with an address, you'll have to take those 5 pieces of data and duplicate it over there rather than being able to reuse that class. So the single responsibility principle is just saying that a class should be responsible for one thing and one thing only, right? What about your project so far? Say in phase 1. How could you express the single responsibility principle here? Well, what were you doing in phase 1? You were doing data loading, right? After you loaded the data, what did you do with it? You serialized it to what? Hopefully we did it to XML, right? Or you serialized it to JSON. Right? How many things does that sound like to you? 3. How many classes is that yelling out to you to make? 3. Right? Now we didn't grade too harshly on it, but you probably want to refactor your projects if you didn't do this, because data loading is independent of everything else. You're going to be changing your project. Hopefully you've read ahead as well. You're going to be changing your project that you're not going to be reading from CSV files in the future. Once you've created a database, designed a database for this, you're going to be loading it up from the database instead of the bunch of CSV files. And if you've intimately woven your code together with these 3 responsibilities, it's going to be a little bit more difficult, not too difficult with this simple project, but a little bit more difficult to extricate those 3 things, right? You'll probably want to go back and refactor it so that these are separate, right? Now, the most egregious violation of this would have been to do all three of these things all in one big, in main or something like that. That's taking it and crossing the line and going 100 feet beyond it, right? You'll definitely want to split that up. I mean, the first thing you probably thought to yourself, I'm going to have a function to do 1, I'm going to have a function to do 2, I'm going to have a function to do 3. Well, now that you're in object-oriented programming, think about separating those functions out into separate classes as well for code organization. Right? All right. So the second one, solid principles, O stands for open closed principle. Right? So the idea here is that every unit that's module, that's classes, that's whatever, right? Every unit, module, method should be open for extension and closed for modification, right? This is just simply classical inheritance. That a superclasses provide general behavior that should not be modified once the hierarchy has been designed, and subclasses provide specific behavior, right, that can be modified. Right? So superclasses should be closed for modification, but in subclasses, you can go ahead and extend and augment or change that behavior. What if you violated this, right? And we'll talk about violations of this in a second here. But suppose you had some well-defined functionality in a superclass, and you had, say, 5 subclasses that all depended on it. Right? Now you introduce. Here, I'll spread this out here. Now, suppose you have a new subclass that requires different behavior, right? And suppose that your solution is to modify the superclass. What have you done for those 5 other classes? You've changed their behavior. You've changed their expectations. And that's why it should be closed for modification. Once you've got a hierarchy established and you've got some sort of behavior up here in the superclass, and these 5 other things depend on that behavior, then you don't want to go changing the program at all, right? You don't want to pull the rug out from under these 5 other classes over here. If you introduce a new class that needs to modify behavior, what do? You provide specialization in that subclass. Don't go breaking everything just for the sake of this one new class over here. And that's the idea behind the open-closed principle, right? You don't want to modify it. So, as far as your design goes, right, if there is no general behavior or default behavior, right? If you've got a superclass where I don't know how to get the cost of a product versus a subscription, or assets, I don't know how to compute the value of an asset. That depends on its state, right? Then what should you do, right? Don't define it. Keep it, and then there's this key word, right? Abstract, right? Keep it abstract, and then force the subclasses to provide that behavior, right? Or an alternative is to break functionality down into smaller parts. Right? And this goes back to even just functions. Right? If you've got a function that does 2 things, loads up data and then persists data to an XML file, that sounds like 2 concerns to me. What if you separated those out into 2 different functions? Then it's much easier to modify it so that instead of persisting to XML, it's persisting to saving, is what persisting means. It's saving to JSON instead. Right? But if you put those 2 things into one function, it is much more difficult to modify that behavior. You'd basically have to cut and paste a bunch of the loading behavior down into your subclass. Right? So don't do that. Make sure that you are defined. You have a well thought out inheritance hierarchy, and don't change it, because later on it's extremely difficult to do so. You'll end up breaking your entire hierarchy. Another example that we talked about before. Remember integers, right? Should an integer class be allowed to be allowed subclassed to redefine what an integer is? No. So how did we solve that problem? Right? We made it, or we, as in Java made this closed for modification by making it, do you remember that keyword, final, right? You could not subclass that entire thing. If you have a method that you want to make sure that is closed for modification, you make that method final, and then subclasses cannot change that method. They can add their own methods. You can add methods to a subclass if you want. You can override general methods that you're inheriting. Right? You can do whatever you want as long as you are being judicious about it. You close off certain things and then open up certain other things for modification. Another example from, say, your project or your lab, for example, Lab 5. Right? What was a universal behavior there? One thing that I saw as a universal behavior was get taxes. Right? How is get taxes defined? Gross pay times tax rate. Now, what was not universal? The tax rate, right? Or how those two constituent things actually were not universal. Getting the gross pay, if you were an hourly employee, it was the number of hours times per hour. If you were salaried, it was just this one number, right? Times tax rate, you may have a different tax rate for depending on what it is. But what is universal about this? What should be closed for modification? How taxes are actually computed. Nobody's going to change it so that it's, zero. I guess you could, right? But then then you're not paying your taxes, right? So what about your project? What's one thing that's maybe universal? And hopefully you've read ahead because that's what you've been doing. Did last week to read the business rules. Hopefully you've been doing that over the last 2 days in order to formulate a nice design document draft where you're talking about the business rules. We have different kinds of assets, right? Well, tell me one thing about those assets. They all have what? All right, they all have a code, right? They're all what? A label. They all have the commonalities. What should be in the superclass already? Labels, codes. Think about behaviors, though. What's a universal behavior? So an asset has value, right? Is the value a universal? No. The value changes, right? So what should be open for modification or for extension? How a value is computed. Right? But what should be closed for modification? Right? So if I purchase, say, a home for $100,000, and then now the housing crisis, it's worth 2-3 years later, it's worth $200,000, right? My asset has gone up in value. That's called a gain, right? So what should be closed for modification? How gains or losses are computed. Why? Because it's simply just one number minus another number. The current value minus my original purchase value, that's its gain. $100,000 gained in that asset, right? Is that going to change depending on if it's a property? What are the other two types, by the way? 3 types, actually. What else is there? Cryptocurrencies and stocks. And then the fourth one is options, right? So one thing that's closed for modification probably is how gain is computed, because that's just a number, right? But how the value that it's based on, that ends up getting changed. So got to spell this right. Modification. Right? I'm outlining in broad terms what you should be thinking about with respect to your design this week. Right? Now, what about the L? Right? L is actually named for a person, Barbara Liskov. I posted a video of her talking about this this thing that in retrospect seems obvious, But at the nascent, creation of object-oriented programming principles was not altogether obvious, and so they had to come up with a mathematical expression of this. And so she talks about the history of coming up with this principle, and of course other people named it after her. I don't think that she called it my substitution principle, right? That would be kind of weird. But if you're the first one to discover it, or you're the first one to describe it, then ultimately you get credit. And it's ultimately described like this. If S is a subtype of T, then objects of type T may be replaced with objects of type S without altering any of their desired properties of T. All this simply means is subtype polymorphism. Subtype polymorphism. Right? For example, let's go into Java mode here. Right? I can have an array list, right, of, say, integers, right, numbers, is equal to new array list. But I should also be able to treat this as its supertype. So if I have a list of integers, right, some list, right, I can say numbers. Alternatively, I could have a different type of list, say a linked list. Numbers 2, right? And I can change some list to that other list without any properties breaking, right? I can say that some list is now equal to numbers 2. Right? The Liskov substitution principle says that a well-designed inheritance, you'll be allowed to do something like this. Why? Some list is just a list. Does it matter that it's holding it in an array? Or, as we'll see later on, a linked list is a bunch of nodes. Here's the first node. It links to the next node. It links to the next node, et cetera, et cetera. It's like a chain, right? And it's not stored in one contiguous array. It's stored in these individual nodes. Does that matter? No, it's just a list. It holds stuff, right? Here's the first element. Whether or not it's at index 0 in an array or it's at the first node that you encounter, it doesn't matter. I can treat subtypes, either array list or linked list, as its supertype. And I can interchange them and nothing breaks. Right? A counterexample to this, or a violation of the Liskov substitution principle, we've already seen. A violation would be the rectangle square example. Now remind me, what did we do with that example? Are all squares rectangles? Yeah. Are all rectangles squares? No. Nevertheless, we went and put this into a hierarchy. Shape, rectangle, square. But we left it open so that you could change the square so that it was not a 10 by 10 square anymore. It was a 10 by 5 or 20 by 10 square. Is that a square? Nope. Even though it was initialized as a square, it's now semantically it's a rectangle. Right? So a violation of this would be not a well-defined hierarchy. That it would be a violation of the Liskov substitution principle because depending on what you set things to, it can no longer be treated as a rectangle, right? Or as a square, excuse me. Now it has to be a rectangle. Right? For this, let's think about your project. And for this, I'm going to ask you, think about how many types of options there are. So for those, hopefully, that have read the handouts, how many are there? Say what? 4? Okay, let's think about 4. Right? List them out for me. What are the 4? What are they called? There's a put and a call, right? And technically, those are the same thing. It's just that you're switching around the seller and the buyer. But since the portfolio is from the perspective of the owner, right? Sometimes the owner is a buyer, sometimes the owner is a seller of an option. So we do have 2 different types of those. But then you said 4. Why? What are the other 2? Right? These kind of have a subcategories, right? These have a short call or short put and a long put, right? And then you have a short call and a long call. Right? Let's take a look at the puts, though. And I forget whether or not you're the buyer or the seller. It doesn't really matter. Long versus short. If you're shorting a stock with an option, what are you doing? you're making a bet that the value will go down. Right? If the value goes down, you make money. If the value goes up, do you make money? Nope. You end up with a long, right, put, because you're losing money. Short, long, right? Are those really types? No. What are they? How do you get? Here's a put option. What determines if it's short or long? The stock price, right? The stock price changes, right? Think about the rectangle square problem. We've got a square. What changes? One of the dimensions, making it not a square anymore, but a rectangle. If the stock price changes, it changes from a long to a short, right? So, should you actually define for? Probably not, right? Short and put, likely, are good types, but long versus short, those depend on the stock price. And the stock price can change. It can go up and it could go down, right? Whether or not you're a loser or a winner in that situation. And so, just like the rectangle problem, right? One thing could become another. If you had defined all four of these and the stock price changed so that it was no longer a long put, it was now a short put, right? Then you are violating the Liskov substitution principle. So keep that in mind. Right? Sorry, what? Oh, maybe. I'm not sure. Whatever the examples were. Again, I very hesitantly made. I thought it was I wrestled with whether or not it was going to be too complex, or not. That's why I gave you a copious amount of examples to work from in the handout. Remember, you need to check out section 3.4. The short, or sorry, this is what you mean. Sorry. Call and put. That's what you meant? Oh, okay, sorry. Yes, it was just a typo. I thought you meant that it changes from a short, instead of changing from short to long, I was pretty sure that it changes from short to long versus it's a fixed call or a put, because a call, and unfortunately I forget which one it is. If you are undercutting, like if you're selling the option to buy or selling the option to sell, right? Or buying the option to sell, whatever, right? It's just a back and forth. It's just a point of view, basically. Right? Are you the seller or are you the buyer of that option? So how many options should you probably have? Probably just two. Okay. All right. That's the Liskov substitution principle. Make sure that your stuff is in a well-defined hierarchy. Don't lock things into a hierarchy and do an inheritance hierarchy if it doesn't make any sense. Right? All right. The I of the solid is interface segregation principle. Right? So the idea here is that no client code, that is code that uses other code, should depend on methods it does not care about. Right. So for example, suppose that I'm doing a graphical user interface application, and I've got a click event handler. Event handler. There we go. In other words, when somebody clicks on a button or something like that, I want to define code that allows me to say what happens when that button gets clicked. Suppose that that's an interface, is an interface that defines two methods, on click and on double click. There we go. So it's a save button. And on clicking this button, it ends up saving the file. But if I end up with this interface here, and I want to implement this, what do I end up having to do? This interface is forcing me to do two things, even if there's one that I don't care about. Click, that saves the file, right? Well, what happens when you hit the save button with a double click? It also saves the file? Right? Okay, that's a reasonable solution, but that just means that I have to write code to either cut and paste the exact same thing in the other function, or I have to have one function call the other function, right? That interface is forcing me to decide to do implement both of these things, even if I don't care about it. Right? Instead, what should happen? Instead, all interfaces should be as small as possible. Right? You should not be forced. No one should be forced to implement everything, because what you end up doing is you end up doing nothing. Right? I don't care about this method, so I'm forced to go ahead and put it in there and then not put any code in there. Or I'm forced to have that code and then I'll throw an exception that this is an unsupported method, right? And then now all the problems become runtime problems instead. Whereas if I had only had one method in that interface, say click event handler, and then I had a different interface that said double click event handler, I could implement both of those if I chose, or I could implement one, or I could implement a different one. It goes back to this example, the simplified example of Lab 5, right? What if I had put person and payable into one interface? Right? Then interns are now payable because they're people, right? They are people too, right? But then what would be my implementation of payable, get pay, for an intern be? Return 0, right? Why am I forced to write code that doesn't make sense? All right? On the other side, what if I make a person and payable one interface, and I say that a supplier is now payable, right? Well, is a supplier necessarily a person? No. So I'd have to end up returning null, or I'd have to say, well, I'll go ahead and return the first name, which is the name of the company that the supplier is, but then return last name, I'll return null on that, right? It gets into weird designs, right? By having one big giant interface, you're forced to do all these things. Another example here would be the collections hierarchy. All of these interfaces, except for collection and list itself, all of these interfaces up here are either one or actually in some cases 0 methods. I've got array list up here. Here are all the known all implemented interfaces, right? Clonable, iterable, collection, list, and random access, and serializable. Serializable. There's not even a single method in here. It's just endowing a list, or an array list in this case, with an actual property. And that property means something if you read read all about it. What about clonable? All objects are clonable because you have an object.clone. But this is giving it additional properties that without defining any more methods. So again, 0 methods. What about iterable? Only 3 methods. And in fact, these 2 methods, splitterator and for each, those are added in Java 8. It used to be for 20 years that there was only one method defined in this interface. Collection and list are going to be a lot larger because, of course, they mean a lot more. But they are still not too big, right? At most like a dozen methods that are defined in this interface. List is a little bit bigger, maybe 24 methods, but they all do something very specific and very useful. Random access, again, we're back down to 0 methods. You want to segregate your methods as much as possible, or your interfaces as much as possible. You don't want to have one interface that does too much. If you have too much, then that means that to implement this interface, you're going to be forced to do all of these things. Later on, when you write your own list class, your own sorted list class, you're gonna have the thought, well, what if I have it implement the list? Let's see, where is it? The list interface. If you make that design choice, guess what? You've just decided that you are going to be forced to implement a dozen methods that you may or may not even want to use. Right? So segregate out your interfaces as much as possible. They should do as little as possible. Now, this doesn't necessarily, impact your project because we're not expecting too many interfaces. But for example, suppose in a project I created an interface that had both a get address and get name right? Because I'm thinking about people here. Everybody has an address. Every person object has an address, and every person object also has a name. But what else has a name? Assets also have a name. In other words, a label. So what if I forced all assets to implement this interface with these two methods here? Does it make sense that an asset has an address? Does the stock live at at 1060 West Addison? No, right? So don't do that, right? In fact, in this case, I'm not even going to. I'm encourage you to define an interface. You probably don't want to, right? But if you do end up defining interfaces, they should be as small as possible. One method, maybe two methods, 3, 4, 5 methods. Really rethink what you're doing there. Right? Not everything is universal. Something that is universal would be labelable. Labelable, right? All assets have a label, right? And you could say that people have a label. What would a person's label be? Maybe a person is labelable. Labelable? Is that even a word? I don't know if it's a word, but it's okay. All right, labelable, their name, right? And you could take that opportunity to get a formatted name, last name, comma, space, first name. And that's the label of the person. I'm not telling you to do that. In fact, I would discourage you from doing that, but that's just a contrived example of what you might think about doing, right? Okay. Let's see. Questions so far? No? Then let's look at the last one because it's the coolest. The D of solid, dependency inversion principle. Now again, this is not going to necessarily come up right now in the project, but it certainly will come up later on when we start looking at, in fact, in the next topic, databases. So high-level modules, in this case classes, should not depend on low-level modules. Instead, both should depend on abstractions. Okay? Now for this, I'm going to have to fire up my iPad over here, and let's take a look at this. So here's the high level, and there's a low level thing, right? This is a class, and this is a class. This class depends on this class in some way. It could be through inheritance, or it could be through composition. Remember composition? That a person class owns an instance of an address class, or an option class owns an instance of a local date class, because options are from a certain date to a certain date, right? So if we have this dependency here, depends on, right? Then what if you want to switch that out? What if you want to switch that low-level thing out for another thing, right? So low-level A and low-level B, right? What if you want to switch your client code up here, this high-level thing, this class, to depend not on this one, but on this one now? For example, you found a better library, or you found a better math library, or you found or the old one here is no longer supported. As some of you have seen, Object Date is now dead. So how are you going to generate your UML diagrams if you choose to do so? You're going to have to draw them, right? So what if this is no longer supported? Or what if they went from a free model to a paid model, and we don't want to pay? That means that we need to change our code, right? We need to modify potentially all of our code to now depend on this new low-level thing, whatever it is. So let's look at this with an actual example. And it's going to be it's going to be a faked or mocked-up example. But suppose that we have a phone app that does geolocation stuff. And suppose that we have 3 different libraries to choose from, right? The compute a location, a GPS location. Suppose that library A has these 2 methods, static, whatever, right? That allow us to get a latitude and allow us to get a longitude, right? Now suppose that library B, I don't know, it's a native Android GPS library or something like that. Android native.getLocation. And once we've got that location, it's an object, we can get the latitude and the longitude of that location. In other words, we have to use this library differently. In the first one, we would have to make two function calls, right? Static function calls. For the second one, we actually have to get this location object, and then we could call the two getters on that location object. And now suppose that we have yet another library, library C, that doesn't do just GPS, but it does GPS along with cell phone tower triangulation or something like that. So it's a much more sophisticated library. And it's cell tower GPS.get latitude, but in this one, they're in radians, right? And maybe in the first library, they were in degrees. 0 to 90 degrees, 0 to negative 90 degrees for latitude, and then 0 to 180 and negative 180 for longitude, whatever it is, right? So what if I needed to write code to interface with one of these three libraries? What would it look like? It would look something like this, right? I need to get the latitude and longitude. So I make a bunch of if-else-if statements here. Right? This is not real Java, so it's not going to end up formatting correctly. But in the first case, if I'm using library A, I have to go and create a brand new location by getting those two latitude and longitudes. If I'm using library B, then I have to get this other object here, this Android location L, and then call its latitude and longitude. If I'm using library C, I have to convert radians to degrees and then create my own location. Right? So this is client code. This is code that depends on these three sub things. Right? And the picture that we've just drawn in this design, in this poor design, bad design, is that our, phone app now has three dependencies, right? This is library A, library B, and library C. Right? We don't like this. What I want to do is I want to sever this connection. I want to make sure that the client code, the high-level stuff, and the low-level stuff can act independently. And so what we're going to do is we're going to sever that dependence and put something in between. Here's our phone app. And here are our three libraries, A, B, C. And you'll note here that instead of this hierarchical dependence of top to bottom, I am drawing it left to right. And what we're going to put in the middle here is an interface. Right? And the phone app will use this interface. And each one of these three things, there will be a wrapper class that, and each one of these implements this interface. Right? These are just wrapper classes. And the idea here is that each one of these wrapper classes takes one of these pieces of functionality. The wrapper class for library A will simply just call GPS locator, get latitude, get longitude, and it'll return a location. The second one will get the Android native thing, rip out its latitude and longitude. The third one, the wrapper class will be responsible for converting radians to degrees. Right? And once I've got this, I no longer have that dependency. I have a loose coupling. This is loose coupling. Right? Coupling means, coupling them together, connecting them together. This is our connection right here, right? The interface in between. Why is this better? Right? What if I come up with a fourth library? Fourth library B. Or B. D. Here's my new library. Where does it fit into the scheme of these things? All I have to do is make a wrapper class that implements this interface. Did I have to change any code over here at all? Nope. Right? Whereas if I had had this solution, what would I have had to do to introduce a brand new library D? I have to change the client code. Right? I have to have this huge series of if, else if, else if, else if, else if. What if I need to deprecate a library because, Android no longer has this native interface anymore? Right? What do? I keep this and then add on logic that says if you're on an old phone, go ahead and continue to use this? No. Right? That's what I would have to do if I had that design. But with this design, do I have to worry about the client code at all? Nope. No changes necessary. It depends on this interface that gives back this location. Right? How it does it? Well, that's dependent on these wrapper classes and the actual library that you're using. Here's another example that will be relevant to your project as we get into databases. Here's your project code. It needs to connect to a database. What kind of database do you want to connect to? Does anybody know any databases? No? MySQL, okay. Right. Free, cheap, old. Right. That's what you will be using. You'll actually be using MariaDB, which is a FOSS version of MySQL. Right. Written by the same person, named after his daughter, I believe. Right. What other kind of databases are out there? Microsoft folks? Anybody? Access. Oh, okay, Access. Secretary Microsoft folks. Say what? Oh, sorry? Also old, yes. It's a basic Office suite, right? What MS SQL or SQL Server, right? That's the other Microsoft product, and then Postgres. That's what I would like them to install and support, but it's not there, right? So your project code, are you going to write towards one specific database? If so, then that locks you in, right? What if this were a real project and suddenly you went from 100 clients to 100,000 clients? Maybe MySQL is no longer going to suit your needs. You need to upgrade to something a little bit better, or maybe you're willing to pay the few $100 for a SQL Server. Right? What do you have to do? All that code that relied on MySQL, throw it away, rewrite it. Right? Now you need to upgrade. Oh, now it's too costly. Microsoft is forcing everybody to get a Microsoft account now to even have Windows, right? You want to sever your relationship with Microsoft entirely now. What do you have to do? Throw away all the code again and start over and program towards your Postgres database. This is if you don't have loose coupling. Right? What would it look like if you had the dependency inversion principle? I don't like the name, by the way, because it's like you're saying that there's this dependency and then you're simply inverting it. You're not. You're taking this dependency and you're severing it, and you're putting these two things side by side. Your project code will program towards an interface. And for us in this class, that's going to be JDBC. Java Database Connectivity API. It does not program towards a MySQL database. It does not program towards a Postgres database or SQL Server or Access or anything. Right? Instead, each one of those companies provides what's called a driver that implements that interface. And so if you've got project code over here that only depends on the interface, then it doesn't matter if you've got a SQL Server, MySQL, or Postgres. Right? What you have to do to change from, say, going over from a MySQL database over to a Postgres database, all you have to do is take this and drop it in your project and you're done. No, not a single line of code over here has to change at all. Right? Cool? Right? That's much easier, a much better design for modifying your code going forward. And again, it's not something that that you'll never necessarily do directly, but it is something that you need to know about and think about. Right? So again, dependency, inverting a dependency. Oops, I'm not in code mode anymore. Inverting a dependency means creating an interface between the high-level object or class or thing, right, and the low-level library that implements it. And I'm putting that into the actual Java keyword there because that's what you end up doing. You define an interface and then you implement that interface maybe with a wrapper class or something like that. Right? And again, it's not something you'll probably have to implement on your own, but it is something that you will use. All right. Any questions? Any questions on your project then? No? Online we have, does order matter when a subclass also implements an interface, i.e. public class X extends, implements, nope. Well, the syntax order might matter. For example, we've got our ostrich over here. Let me open up our ostrich again. Implements eatable, and it also implements nestable. All right, there we go. So the implements comes after, I believe. You cannot do something like this. Ostrich implements and extends? No. So it extends and then it implements, right? So hopefully that answers your question online. Oh, okay. Somebody else mentions, what could we do here instead of this? Use a switch statement. That would be just as bad, right? Because you still have the same problem. You need to integrate a new library going forward. That means that you're modifying the client code to have another condition in your switch statement, right? So if you have a completely different class with wrapper classes and potentially with wrapper classes and an interface, that is a much better design, right? It's loose coupling, right? In general, you should prefer loose coupling, right? So that software components can easily be interchanged, right? All you have to do is take out that database, put in a new database by dropping in a different jar file. It is actually as simple as that in Java. You put in a different jar file for Postgres, and you didn't have to change a single line of code at all. All right. I have no idea who SEK3 is, but whatever. Somebody else can explain that online. Right. All right, let's see. Do we have any questions on Piazza? Nope. Okay. All right, so that's the sum of object-oriented programming that I wanted to cover. The next module here is going to be databases. And so to motivate that, what I want to do is, I should have pulled this up before, but let's see, lectures. Oh no. There we go. I want to give you an example of a database and then ask you what the problems are, right? All right, so here is a bunch of data on a course enrollment system, right? We've got a course, the course name, the student that's enrolled in that course, their NUID, and their email. This is a flat file representation, exactly what you're working with right now, the CSV data, okay? What are some problems here? What are some problems with this data that you see? Look at that NUID column first of all. How many unique NUIDs do you see? 3. But I see, what, maybe a dozen records there? So what does that immediately tell you about that data? There's repetition, right? There's unnecessary repetition. The same NUID is repeated over and over and over again for John's student there. Now take a look at John's student's name in the student column here. Do you see any anomalies there? Yeah, sometimes it's student, comma, J. Other times it's student, comma, John, right? There's potential for data anomalies like this where conceptually it's the same person because they have the same NUIDs, right? But their names are represented differently here. Right? What about Tom Waits there? Sometimes it's first name, space, last name. And in the first one, it's Waits, comma, Tom. Right? They're what? And it's lowercase, exactly, right? And sometimes there's no comma. Oh, there you go. Well, that's because his first name is Tom, right? Tom Waits. But what about that first one right there? That first record, Waits, comma, Tom. Is he enrolled in any courses according to that record? No. So why is that record there? Take a look at the last column. Yeah, it's the only one that has a Hotmail address, right? We've got two other emails down there, twaits@email.com, and, I guess that's the same one, twaits@gmail.com if you want, right? What about that last one? I mean, why is it there? It's only there to represent that he's got this other email, right? But what about the first two columns? What about the difference between the first record and the last record? How are we representing that he's not enrolled in any particular course for that record versus he's not enrolled in any particular course in the last record? Yeah, null versus empty string versus the string that has NONE, all caps, right? Does this seem like it's a well-represented data? Probably not, right? In fact, it needs to be separated out into different tables. For this, I'm going to go ahead and jump down. In fact, wait, before we go on, should this data even be in the same table here? What kind of entities do we have here, conceptually? We have courses, and we have students, right? Should a course and a student be the same Java object? Probably not. Likewise, in a database, should they be in the same table? Probably not. We want these to be in separate tables with some sort of a relationship between those two tables. That's where relational database management systems come in, right? Also emails, right? That's probably yet another entity that belongs in yet another table. So let me go ahead and run all the way to the end here. And let's look at this data from a normalized perspective. There's the same data. Right? We've separated things out into separate tables. This one right here is a student table and contains student data. Over here, we've got a course table and contains course data. We bring them together with what's called a join table so that one student can be enrolled in multiple courses and one course can have multiple students in it. And then we save off the email, all emails off into this other table over here. Why? Is that what? Yeah, it's certainly an email has nothing to do with a course. Arguably, it has something to do with a student, but what if we were to put it into this table over here? What would we would have one email record for each student? Well, Tom Waits has 2 emails, right? So maybe we have 2 fields, email 1 and email 2. Oh, wait, this person has 3 emails. Email 1 column, email 2 column, email 3 column. Does that sound like a good design for going forward? What if they only have 1 email and you've got 4 email 1, 2, 3, and 4 columns, right? The other 3 will be completely blank. Why are you wasting those? Right? So if we spread it out into a different table, we can define what's called a one-to-many relationship, or a one-to-many relationship and then a many-to-one relationship, and get all of these different relations and model them in a nice, clear table-based database. Right? That's what we're going to be focusing on for the next couple of weeks. We are going to build. We're going to talk about SQL, querying a database, and basic CRUD: create, retrieve, update, and destroy. We will talk about the ACID principle. So we've got yet more acronyms here. ACID is the atomicity, consistency, isolation, and durability. But most of what we're going to be talking about are addressing these problems with that flat file representation. There's repetition of data. How do we reduce the repetition? There's incomplete data. How do we define constraints to say that a person's first name is a required piece of data, or their NUID, right? Their NUID is required, and it also is unique because no 2 people should have the same NUID, right? Because that's a unique identifier. The integrity of data. What if I were allowed to have a course that was missing, or whose name was missing? Or should I be allowed to set a course to NONE? Maybe not. Right? Or blank, or something like that? Maybe not. So I can guarantee the integrity of the data. If it were a numerical piece of data, right, I wouldn't be able to set it to TEN, right, as a string. I would be able to do that with a flat file, right? If there was a number here, like an NUID that we treated as an integer, and I just put in there hello world, right? There's nothing to stop me from doing that with a plain text file. With a database system, there's integrity and typing of your actual data. There's also organizational problems. Any aggregate requires processing of all records. If I did all my database stuff with one CSV file, and I had multiple threads or multiple programs accessing this one file, is that going to be efficient? Nope. This one program comes in, puts a lock on that file, blocking all other programs from accessing that file at the same time, right? In other words, we make everything into serialization, right? That program 1 executes, then program 2, then program 3, then program 4. Imagine if Google worked that way, that only one person in the entire world could actually make a Google request at one time, right? Would you ever be able to get your turn? No. Right? So we want to be able to distribute this kind of work instead of just having one file to work with. Updating information is also difficult, because what if I wanted to change Tom Waits' email here? Hotmail went down. Does Hotmail still exist? Okay. Suppose that they shut down Hotmail, right? And we need to update that. What am I going to have to do? I'm going to have to find every single record in the entire file that corresponds to Tom Waits, check to see if that's the Hotmail account and change it, right? And if it's not, then don't change it. In other words, I would have to process the entire file, right? Now, this doesn't matter because there are only a dozen records here, but imagine if you had a real course enrollment system with millions and millions and millions of records, right? And now you need to process all million records just to change one email of one person, right? Not efficient at all. Formatting issues, concurrency issues, et cetera, et cetera. Right? All these problems are solved with a relational database management system that stores stuff in tables, defines relationships between those tables, data is stored in columns, and records are stored in rows. Right? So it's column, row form. I want to jump to types. Here we go. There we go. So there are commercial RDBMSs, or these are not all commercial. But you mentioned MS Access, right? It's part of the Office suite. I don't know if it comes with a default installation, but if you buy Office, you can certainly install Access, right? Right? Okay. But by default, it's not there because most people wouldn't have a clue as to what a database is, much less be able to use one. Right? They just want to use it for word processing or something to write a report. But MySQL, which is owned by Oracle, but released under GNU GPL, that's a general public license. In other words, MySQL is free, but it is free as in beer. Have you ever heard that term? Free as in freedom, free as in beer. So you don't have to pay for the beer, right? MySQL, you don't have to pay for the beer. You get the beer for free, but it's not free as in freedom. Postgres is true freedom. You can take that software, and it comes with no licensing restrictions, well, some licensing restrictions, but you can modify it, you can sell it, you can do whatever you want with it. It's free of intellectual property rights claims, right? And that's what FOSS stands for, free and open source software. You can do whatever you want with it, including sell it. You repackage it, modify it, sell it, do whatever you want. Other stuff that you might eventually see, Informix is a rather old, and DB2, those are both IBM products. I don't know how much they cost. I haven't looked at lately, but usually big software like that now is on a service cost model where you basically pay rental and you're paying tens of thousands of dollars a year for not just the software, but upgrades and support for that software. SQL Server, I think, is much, much cheaper. A few $100, I want to say. That might also be on a subscription kind of thing. Oracle databases run in the millions of dollars, depending on your organization, right? The UNL's central database stuff all runs on Oracle, and when they set it up, like now 8 years ago, it was the investment was millions of dollars. Right? Then you also have really, really small things like SQLite, which can be built into a browser, or it can be built into a single jar file and not have a server at all. Right? Others might include like, I don't know if they're called, yeah, it's renamed. Google has a database system called Bigtable. It's now called Spanner. I don't know if they've renamed it. Google throws things away and builds stuff and like nothing, right? You can go to the Google graveyard and look at all the products that they've created over the years, the great products that they've created over the years and then abandoned or thrown away, right? There's also Apache Cassandra. That's what, at least a couple of years ago, Facebook was running on. Amazon's Dynamo. These are all, you can access that through Amazon Web Services and stuff like that. So there are plenty of other databases out there. We're going to be dealing with MySQL. Actually, we'll be dealing with, it's not here, but MariaDB. So the last thing I want to show you today is at some point you're going to want to get access to your database. So if you go to cse.unl.edu, account, right, log in using your CSE credentials. I think that's it. There we go. Yep. Account settings. And then, let's see, you currently have a MySQL account on CSE. You may not have this if you've never claimed it before. Otherwise, it'll ask you to click here. It'll send you a reset password that you can then connect to your MySQL database. You should not use the same password as your actual login. In fact, it doesn't really matter what password you use for this because if you're working in a pair, you're going to end up sharing that with your partner. No matter what, you're going to end up putting that into your Java code at some point, the actual password into your Java code, and you don't want to use the same password that you use for your bank accounts or your email or something like that. So it is okay to have a throwaway password for this. In fact, you'll want a different password. I don't know what my password is, so I'll go ahead and click here to have it reset. It'll just simply send you an email with the new password. Right? My recommendation is that you download and install something called MySQL Workbench. In fact, let's work MySQL work. Even though we're not technically using MySQL, we are using a MySQL compatible product, MariaDB, MySQL Workbench. And you'll need this for next week, definitely, when you're doing your Lab 7 and you're connecting to a database and mucking around with it. It's a free download. It's owned by Oracle, put out by Oracle. Let's see, download now. You'll want to select, of course, your relevant operating system. I believe that it's written in Java, so it's completely cross-platform. Did I start it? I thought I started it. Yeah, there it is. Right. So when you start out here, there'll be a splash page with a welcome page or whatever. You can go ahead and create a new connection. Name your connection whatever you want. School of Computing, computing server. Right? It's just the CSE server. I'm using that name here because I've already used CSE down here. The host name will be cse.unl.edu. Do not change the port. That is the standard port for MySQL. You do change the username because none of you are root. I'm not even root. I'm not even in the sudoers group on CSE. They don't trust anybody apparently, right? Your username will be your CSE username. In my case, it's going to be cburk. When you hit OK, you can actually test the connection if you want. When you hit OK, that's when you're going to have then open this up. That's when you're going to have to supply that password that was sent to you via email. Right? And I have no idea what it is. I'd have to look at my Gmail account or my email to get it. Right? But you enter your password in. You can save it if you want. If you change the password, of course, you'll have to change the keychain or whatever. If it's a wrong password, of course, it'll reject you. So let's cancel this. This won't work anymore either because I just reset my password. Wonderful, right? All right. So if you want, I can not on the screen, but I will go ahead and go to my email account here, and let's see. Come on, you haven't reset my password. I haven't gotten the email yet. All right, fine. SSH forwarding doesn't. Is not immediate, I guess. There we go. So you'll get an email eventually that looks something like this. Obviously, if you have a different email client, it's going to look a lot prettier. But there's my password. I will reset it again later on, so don't bother copying it, all right? Then go back over here. There we go. And now I'm connected to the SQL server. I can start typing commands here if I want to. I can execute queries by hitting execute. So let's just go ahead and select my database, or use database, excuse me. Use database. Seberg. You will only have access to one database on the CSE server. That database is named after you, your login. Right? There are plenty of other databases living on there. Right? Your neighbor, they have a database under their login. You're not able to access that, and for good reason. Right? They don't want you just mucking around with any old database on that server. So you need to use your database, and oops, did I use database? Okay, I must have spelled it wrong. Oh, I'll just try it like this. There we go. Use Seberg. Right. All right. Show databases, I guess. Show databases. Yeah, there we go. There's me, and the only other thing that I have access to is an internal database that takes on this schema here. Let me go ahead and close this result here. I'll use my database, and there's already tables in there, but you're not going to have any tables. So show tables. Right. And you see here that I already have, I already did the assignment, right? Because of course I always do the assignment to make sure that it works first. Right? And of course I need a solution so that we have something in the grader. Right? But those are my tables. You can blow them all away if you want by saying drop database, Seberg. All my tables are now gone. Right? Create database, Seberg. Recreated, and you'll see that each one of these is a green check mark, meaning successful. Right? Show the tables now. Oops. Show tables. Use Seberg. There we go. And then show tables. And all my tables are gone. Right? Darn it. That's okay, because I kept all my code in another SQL file somewhere. Right? All right, that's the basic usage. Can you create another database? Create database foo. No, you do not have permissions to do that. You have access to one database. Now, you're going to have several databases throughout the semester. You're going to have maybe a demo data, like a video game database that I provide if you want to do some practice. In your labs, you're going to have an albums database. You're going to have your project database, et cetera, et cetera, et cetera, right? All those tables can live happily together in one database, right? Now, normally in real life, you would want to create a database for albums database, then a video games database, then a project database, assets database, or something like that, and put those tables into different databases. You don't have that luxury because of the way that CSE is set up. You only have access to one database, your database named after your login, and that's it. Right? But it's perfectly fine because multiple different tables can live side by side happily. Right? As long as you don't have like album table for your project for some reason. I don't know why you would though. Right. Yeah, I should have zoomed in there. There, make it big. Right. So that's my SQL workbench. The price is right, it's free. It's not the greatest, but it gets the job done and it doesn't cost you anything. If you want to use something else, Eclipse actually has native support for SQL stuff here. If you want to use something else, that's perfectly fine. It's just that we may not be able to provide any tech support on it at all. All right, that is enough to get you started for Thursday when we start covering databases. And again, you don't need to set this up until next week for Lab 7, but and then Phase 3 and 4 and beyond, you'll be setting up your own database for your project. All right, I'll see you on Thursday then. No questions? No? Okay.